get the best of both worlds. You get all the information from our DEL libraries, so our DNA encoded libraries. And if you add AI on top of that, you also get these hidden patterns that give you more starting points. And so you're increasing your chemical diversity, and that's more hit faster. We've had a lot of success with our traditional approach. Our chemists are really great at teasing the hits out of our DEL data. But if, obviously our libraries are growing, our data sets are growing, so it's going to take a little longer to process all that as all of that grows. And we also need to synthesize our compounds. So if you layer AI on top of what we already have, you help our chemists tease more information out of the data. So you speed up their process, and you can use AI to predict into commercial catalogs, for example. So you're expanding the space. That's, again, more hits faster. As we were going through our proof of concept work, we worked with over a dozen targets, and we quickly realized that we need to have some flexibility in a platform that all targets behave differently. So that really led us to building a platform that was, what we wanted was state-of-the-art, adaptable, and fast. Basically, the platform takes in your DEL data and will apply as many models as are needed and as many chemical representations that are needed to your data set to come up with the best model for your target. And it's really easy to use. We've built in a lot of flexibility, but basically in the end, you need your starting DEL data and you need your commercial set that you want to predict on, for example, plug that in, and the platform takes care of all the in-between. Well, you can do that in multiple ways. Like drug discovery is, I call it a game of statistics. You want to have as many shots on goal as you can have. So with AI and this platform, the fact that you can predict into commercial sets, that you can order compounds from quickly and that are cheaper, that accelerates things. The fact that you can use the AI to help decisions on what compounds to pursue, that's another way. And another example is if you have an internal HTS set that you want to prioritize, you don't want to test all of them, you could use a model to predict which compounds to prioritize. You're reducing costs, not only speeding things up. So I think that's kind of one of the many ways it can help. So we call it HitMiner. It uses our Artemis AI platform to take the DEL data and generate models that can be used to predict into commercial sets. The way it works is you feed in your DEL data, it will convert your DEL data to chemical representations that are suitable for machine learning. It will bin your chemical entities into binders and non-binders. And once it has that, it'll apply as many models as we can to figure out what's the best model for your target. Once we have a final set of good models, we'll use that to predict the commercial sets that we have, and then you move on to ordering compounds. We have all the experts that it takes to make HitMiner work in-house. We have the DEL experts, we have the AI experts, and we really built all of that knowledge into HitMiner. And we've used HitMiner. We have published on the fact that it works. So I really feel strongly that we're putting a product out there for our clients that will get them the results they need. And so if you're curious about it, and I hope you are, please reach out to me on LinkedIn or go to our website to reach out to our BD team.